Hi guys, I'm Deepranjan. So today I'm going to explain you about the k-means clustering. So before going ahead with the k-means, first of all we'll try to understand about the clustering, what exactly the clustering is, and what is the meaning of clustering. So clustering simply means grouping of data. Okay, and clustering is an unsupervised learning approach. So in unsupervised learning approach, we are dealing with that kind of data which are not having a target column, which are not labeled, unlabeled data sets. Okay, so in clustering, if I tell you in the simple words, let's suppose, I'll give you an example, a very basic example. Let's suppose we have given some object, some different kind of object to a child, and I will tell him or her to group them. Okay. Be- So how it will try to group them? Okay. So he or she will try to find the similarity between them based on its shape, size, color, hardness, and the softness of the object, and it will try to and he or she will try to group it. Okay, so that the same thing happening with the clustering also. So clustering simply means grouping of the data based on its similarity or dissimilarity. There is nothing else. Clustering simply means we have to find a similarity or dissimilarity between our data, okay, between our data, and make them in a group, not in a group, with a different group also. Okay, so you can see here in the first image, we have a four clusters, one, two, three, four, and this one also having a four clusters, four groups of data. And this circle, if you can see, this is called as centroid. We'll discuss about it just in a few minutes. Okay. So let's first understand what are the applications of clustering, where we can use the algorithm. So we can use clustering for the customer segmentation. Like if you can, like if you have a data set which are having a customers like a person's income and a person expenditure. Based on that, we will try to organize our marketing campaign, like how they, we will reach to which kind of people, like tier one people. Like based on their expenses, we will try to find analyze that whether we will provide loan to that customer, a credit card or something like that. We will try to analyze it. Okay, and for data analysis, like let's suppose if we have a huge amount of data, and use means like a 1 million of record of a data, and if you try to perform a data analysis on that kind of a data, then definitely it there will be a very it will be a mesh. Okay, so we will just try to cluster them. Okay, we will just try to find a similar instances and cluster them, and try to analyze that kind of data. And clustering we are using for the dimension reduction also, for for anomaly detection simply is an example. If you can take of spam or ham detection email. For semi-supervised learning approach also, as I already said, clustering is an unsupervised learning approach, so definitely it will work with the semi-supervised also, for search engine, for segmentation. So now first we will try to understand what exactly the k-means clustering is. So it is proposed by Stuart Lutz at the Bell's Lab in 1957. So you can see that it's a very old approach that we are using, but it's still very effective. Okay, so we are using it. Uh, so these are the theory part. That will be little bit boring. Okay, so I'll try to explain you by using the paint. Okay, actually I don't have a pen in Twitter, but I'll try to make it. Okay, try to explain it. So let's suppose we are going to discuss about the K means clustering. K means clustering. Okay, that's fine. So here K means, in K means clustering. Okay, we are first we'll try to randomly select the value of K in K means cluster. Okay, we are randomly selecting the number of cluster. K is simply the number of clusters. Okay, And let's suppose we have a data points. Let me draw some data points. That will be good. Sorry for this noise. Actually, I don't. Uh, this doesn't provide to mute this thing. Okay. 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 Fine. 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 So let's suppose we have a data set. Okay. And we have taken the value k is equal to 2. One is here and one is here. Randomly, we have selected the value of k, that is 2. Okay. So now, uh, if you can know about that, we have learned in the 10th or 12th also to find centroid. Okay. So what exactly centroid is? Centroid is something like finding a middle point of our object. Okay. So let's suppose if we have one data, only one data, just like this, one data. So centroid of this data and centroid of a single data is zero, right? And symbol of this data is also zero. Okay. So let's suppose this is the data. Okay. And what we are doing exactly here, we are trying to find out the centroid. Wait, let me draw a line, this one and this one. So what exactly in k means it is doing, it is trying to find out the centroid. Let's suppose this is our data and these two are our k value, randomly selected k value. So whichever k value, like the data and the k value having less distance between them, that that they will create a cluster. Let me draw it. Let me select some shape. Eclipse will work, I think. Okay, sorry about that. With me, I think I have to use the paint only. Plus, sorry about this noise, guys. So, if you can see here, this data and this point is having less distance as compared to this data point. So that's why we are trying to find a cluster here. Okay, trying to find a group here. Okay, based on this distance. Okay. And if we try to find the centroid of these 2 points, that will be somewhere here. Wait a second. That will be somewhere here. Yeah, right. That will be our new centroid. So now the our k value, this k value moved to this one. Okay, right. This one, this is our new centroid, and this is another centroid, right? So now again, Uh, this is our new centroid. So let me erase something so we can proceed with another one, another example. And so at that point, this was our new centroid, right? So now we will select another data point, right? This one, okay. So we'll draw again. We'll draw the same thing, same line between those points. Okay. So now again we will try to find out, right? This, okay, there was one more data, right? Yeah. Sorry, and those are in group. Those are in a group, right? So now if you can see there, the data, this point is near to this point, so definitely it will go into this cluster only, and then again there will be one new centroid that will come near to that, near to this one. Okay, near to this one. So in that way, in the same process, like this same kind of process, we will perform for the for all the data points, and we will try to find uh, two groups, because we have taken data, because we have taken random value random k value as a key. So these all data will be divided into two separate groups, right? So after dividing our data into the two separate groups, we will do one more thing. There is a concept called WCSS. So what exactly WCSS is? Within cluster, let me do it here. Do cluster submission square. So within WCSS, its full form is within cluster submission square. It's a square, not fine. So what exactly happening in this within cluster submission of a square? Let's suppose, let me take some points, random points here. Okay. So, if you know, I already told you, each point is a centroid, right? And that centroid having a value 0. Centroid value is a 0. So, what exactly happening in the WCSS? Uh, so, let's suppose if we have a k value that is equal to n, at that point of a time, our WCSS value will be 0. Okay, and if we form a cluster, if we form a single cluster, if we try to form a group, a single group, at that point of a time, our WCSS value will be maximum. Okay, and if we try, if we divide this data set into two groups, then our WCSS value will decrease. If we do it in the three groups, then it will also decrease. Then in four groups, then it will also decrease. After some point of a time, okay, there will be a very small change in the WCSS value. Okay, so what K means is doing, in K means we are trying to find out uh, the WCSS value. Okay, first of all, we'll try to uh, randomly select K value, and based on that K value, we are trying to find out the WCSS, and that WCSS value we are plotting it. We are plotting it, the WCSS value, with respect to the K. So if you can see here, okay, now come to this document. Okay, yeah. So here I have mentioned the steps also. First of all, we have randomly selected K centers, and we have calculated the distance of all the points from the K centers and allocate the point to cluster based on their shortest distance. Okay. Here the model inertia. Model inertia is WCSS. Okay. And once all the points are assigned to the clusters, like as we have gone with the k is equal to 2 clusters, as all the points are assigned to these two clusters, then we recompute the centroid. We recompute, like we'll find a centroid of that cluster. Okay, and we'll repeat the step 2 and 3 until the location of centroid stop changing.